So good day everyone. I'm gonna lecturing you about electric circuit analysis. So I'm giving you a simple introduction on this subject. So these are the things that we're going to learn in this lecture. So first is the basic concept, charge, current, voltage, power, resistance, and circuit elements. So this are we going to learn in this lecture. So first, let's define what is electrical circuit. So by book definition, is an interconnection of electrical elements. So what are these electrical elements? So this may be batteries, resistors, capacitors, inductors, and transistors, and any kind of electronics or electrical components. So muna siya ang electrical circuit, interconnections of electrical elements. So to give you example, I'm gonna show the basic electric circuits. So the most basic electric circuits consist of a source, connection, and a load. So this is the example of a basic electric circuit. So we have in here, I'm gonna change the point, this is a pointer now. So we have here, so we have two types of diagram. So we have the pictorial diagram and schematic diagram. So similar na silang dua, but in different columns siya pag-draw. So we have here a source, a connection, and a load. So ang source nato here is a battery, the connection using through a wire, and a load using a lamp. So this is a basic electric circuit. So matawag rin siya nga circuit if you have um, this type of connections. So mga basic electric circuits. So first, let's define what is charge. So charge is the most basic quantity of electric circuit that measures the electrical property of an atomic particle which matter consists, where measurement unit is in coulombs with capital C. So charge is represented with a letter Q. So Q ang yung representation. Then ang unit niya is in coulombs with capital C. So this is the equation of the charge. So 1 coulomb is equal to 1 over 1.602 times 10 to the power of negative 19, which is equal to 6.24 times 10 to the power of 18 electrons. This 1.62 is the value of this electron, because the one that travels through the conductor is an electron. So that's why we need to use the value of an electron. So to give you an idea on how charge is being measured, so for example, since electron man ang ito gina-measure, so for example, in this cylinder, so this circle dre na negative, so that represents the electron. So kung daghan kag electron here na nagtapok, or nagtapok, so we can measure the number of electrons through using columns. So muna yung purpose sa columns. So to measure, if you measure the number of electrons that is consist on this particular conductor, so we can now know how much the charge is in that conductor. So munang measure niya is in coulomb. So it measures the number of electrons in that conductor. So that is a simple way to explain the charge. So to use the formula that I given earlier, so for example, we have this question: how many charge is represented in 4,600 electrons? So we know that one electron is equivalent to negative 1.602 times 10 to the power of negative 19 coulombs. So this is just a simple multiplication. So you just to multiply 4600 times the value of electron, which is here, and simple using calculator, so we get negative 7.3692 times 10 to the power of negative 16 coulombs. So next is a current. So what is current? So it is the time rate of change of a charge that is measured in amperes. So current is represented by a letter I, and its measurement is in amperes, which is in capital A. So what is the equation of a current? So since it states the rate of change, so it means we use the derivative, because that is the purpose of derivatives, is to measure the rate of change. So that's why the equation is in derivative format, or derivative form. So since it states here the rate of change of charge, so it means that the derivative of a charge, which is Q, so derivative sa charge. So how current is being measured? So unsa jud ang current? So for example, similar figure earlier, but we have this arrow, so to point which direction is electron is flowing. So di ba, I stated there earlier na ang charge is the measure of how many electrons exist on that particular area. So mo na measure sa charge. Now, if that electron move on certain directions, so it means that there are a flow of electrons. So if there is a flow of electrons, it means that there is a change of charge on that particular area. So since there's a change of charge, so that change of charge is a current. So ano siya, it's about in this definition. So the changing of, or the movement or the flow of the current is of flow of the electron is current. So to measure the flow of the electron. So ano siya. So there are two types of current. So we have this direct current. So is a current that remains constant with time. So looking at the graph, so the value or the magnitude of the current is constant lang throughout the time. So same value. So that's why it's called DC. So next is alternative current, which current that varies sinusoidally with time. So looking at the graph, so it forms a sinusoidal value for the current. So nag-vary siya from positive to negative. So it forms a sine wave, somewhat sine wave. So like that. Muna siya mga tawag og alternative current. So this is the difference between the DC and the AC. So for example, using the equation that for the current, the problem is the total charge entering a terminal is given by Q is equal to 5t sine 4 pi t millicoulomb. Calculate the current at t is equal to 0.5 seconds. So how to calculate this? So we know that the formula of a current is I is equal to derivative of a charge. So since we are given with this equation in here, so we can substitute this to this formula. So substitute the value of Q in here. So we get the derivative of this equation. So wait, I'm gonna change the pen. So derivative of this equation. Now I'm gonna assume that you know already the basic rules of deriving the equation. So since this is, we have two variables that exist in this equation, so it means we use a product rule. So how to use a product rule? So first is to derive this this variable, which is 5t, retaining the value of sine. So the derivative of that is a is equal to 5 sine 4 pi t. Next is the derivative of a sine retaining the value of the 5t. So which is 5. 5t is equal to cosine 4 pi t times 4 pi. So why name mo siyang in this format? Because before deriving the sign, so we need to use also the chain rule. So deriving the outside, which is the sign, which is it makes 4 pi, and next is to derive the inside, so which is 4 pi. So simplifying the equation, we get 20 pi t cosine 4 pi t. So after that, we need to add these two equation, the a and b, to form a product rule. So that's it. So after adding the two derivations, so we now made the result of a product rule. So we change this into milliamps because the derivative of coulombs is amps. So after that, uh, we need to substitute the value for the time. So in this given, we have the value for the time, which is t is equal to 0.5 seconds. So substituting the value of 0.5 in this equation, so that's it. So substitute lang, and then simplify the equation, we get 331.42 milliamps. So note that you need to change the parameter in your calculator because we are dealing with pi. So it means trigonometry, then ay pi siya sulod. So therefore, we need to change the calculator into a radian. So mo na siya makakuha ng 31.42. But if you don't change the in your calculator into a radian, na siya difference gamay. So gamay naman sad, pero you need to change settings in your calculator para makuha yun yung exact value for the current that is needed to solve in this problem. So ano siya. That's how simple to find and use a derivative to find the current. So next is our voltage. So what is voltage? So it is also called potential difference. It is the energy required to move a unit charge through an element measured in volts. Diba earlier stated that charge is a measure of how many electrons exist on that object, on that area or volume. And current is a measurement of a flow of the current or the rate of change of the charge. Now, what causes the electron to flow? So the one that cause the electron to flow is the voltage. So if there is a voltage, it means uh, there is an electron flow. So based on based on the figure, so the electron is flowing. So therefore, there is a voltage that is pushing the electron. So the one that pushes the electron is the voltage. So muna siya ang purpose sa voltage. So tigtulod ko hay. So this is the equation of the voltage. We are not going to use this, so don't worry. So only the current. So this we are not going to use this because this is not always used in circuit analysis. So next is the power. So what is power? So it is a time rate of expending and consuming energy, which measure in watts. So power is represented by P and measured in watts, which is in W. So this is the equation of the power. So P is equal to the derivative of work with respect to time. So to simplify this equation, so may mo siyang P is equal to VI. So power is equal to voltage times current. So I'm gonna give you example how to use this formula. So to give best example is to have a circuit itself. So we have this a simple circuit in here. So we have a load which is here, source. This is source, voltage source. This is a voltage source, and then we have a given current which is here, 5 amps, and then a simple load which is a resistor. So this is a symbol for resistor. So the problem is, what is the power that is experienced by this resistor? So using the formula, so the solution is P is equal to VI. So we have this, then substitute the value that is on the circuit, which is 10 volts and 5 ohms. And then simplifying, so we get 50 watts. So therefore, this resistor has a, consumes a 50 watts of power. So that's it. That's how you solve the power of a certain load. But there is a certain rule that you need to follow before solving the power, and that is a passive sign convention rule. So you need to remember this, because this rule will be used throughout the subject. So any type of electric circuit analysis, you're gonna use this. So you need to remember this always. So the rule states that when the current, so you're gonna remember this, when the current enters, so these are the things you need to remember, enters through the positive terminal, so the power is P is equal to VI. So if the current leaves through a positive terminal, it the power should be negative, so negative VI. So you're gonna remember this: if enters, positive, but it leaves in positive terminal, negative. So to better understand this rule, so I'm gonna give you an example. So this, we have this diagram in here. So first let's check this figure A. So figure A is a top. So now let's check. So we have this a current here, in this current above, which is I, pointed in this direction, right? And then we have this a terminal in here, which is positive in this and negative in here. So now, how are we going to use the passive rule convention? So let's check. So let's check first the direction of the current. So since the current is pointing towards left, so therefore the current is flowing in this path. So like that. So the okay, that is the flow of the current. So since that is the flow of the current, so we're gonna check where the current is entering or leaving. So since the current is entering the passive, this this positive terminal, so it means that the power should be positive based on the rule that is stated. So now, if we look in this figure B, so if the current is leaving through a positive terminal, which is here, because why it leaves, because the arrow, the current is flowing from this direction to this direction because of the arrow, so where the arrow is pointed up. So it means that it leaves through the positive terminal. So therefore we can assume that the power, or not assume, but the power is in negative terminal, a negative value. So muna siya ang pasabot sa passive sign convention rule. So to give you an example, so for example here, so let's first solve A. So using the passive sign convention, so we're gonna look the direction of the current, which is here, pointed to that direction, and so therefore the direction of a current is in clockwise rotation. So since the current is entering in this node, in this positive terminal, therefore the power that is experiencing or consumed by this load is in positive. So yeah, positive. So substituting the value, 4 volts and 3 amps, we get 12 watts. Next is letter B. Now, what should be uh, the sign convention of the power that experienced by this load? So looking at back again to the direction of the current, so it goes to the left. So it means that the current is flowing starting from here to this direction, towards that direction. So it forms a counterclockwise rotation. So since it goes in counterclockwise direction, so it means this is where the current started, right? So looking at the terminal of the circuit, it enters with the positive terminal. So therefore, since it enters the positive terminal, we assume or we know that the power that is absorbed by this terminal is in positive form. So P is equal to VI, substitute the value, and same again. 12 volts. Okay, kaya igor man siya ni mo siya gi inverse na ni mga circuit. So next is resistance. So what is resistance? According to the book, a measure of the opposition to current flow in an electrical circuit that is measured in ohms. So represented R is representation of resistance, and it measures with ohms. So omega ang symbol. So the formula of resistance, a simple formula are we going to use are the Ohm's law. So this is the Ohm's law. So the Ohm's law stated that the voltage um, is equal to current times resistance. So meron siya ang Ohm's law. So this is the most used formula in the entire electric circuit analysis. So the Ohm's law. So to better understand what is resistance, so we're gonna have an analogy on what is the resistance. So given the figure, for example, we have the circuit, we have a basic circuit, we have a battery, which is a source, uh, a wire, and then a load, which is a resistor or resistance. So we're gonna compare it into a pipeline, simple pipeline. So this is the analogy of the circuit. So for example, here in this part, so we have a tank. So this water represents the charge, and this volume of tank in here is represents the voltage. So since we have a large amount of water in here, so it forms a pressure. So the pressure that it forms is somewhat similar to voltage. So sa pressure mo nag-push sa water towards in this direction. So mo siyang similar characteristics sa voltage. Now, that flow of water in here, so kung unsa siya, how fast the flow of the water is the current. So mo siya stated here, the volume of water passing giving the point each second is similar to current. Now this part in here, in the small pipe, that is the bent pipe in here is somewhat similar characteristic to resistance. So it is a constriction. So based on the figure, so it's somewhat it prevents the water to flow in this direction. So muna siya ang analogy sa resistor or resistance. So it prevents the current to flow in these directions. So it constrict the current to flow in this direction. So I'm gonna give you a simple example on how to use the Ohm's law. So given this figure in here, this figure. So for example, we have this voltage in here with a value of 10 volts. 10 volts na siya. So 10 volts. And we have this resistor in here whose value is in 100 ohms. So the question is, what is the current that is flowing in this direction? So what is the current in here? So ang current in here. So now we're gonna use the Ohm's law. So to use the Ohm's law, so here the formula, Ohm's law, since the current since current man ang we're going to find, so we're gonna rearrange the formula. So we get I is equal to V over R. Now we are given a 10 volts and 100 ohms, so substitute the values, then simplify, and we get 10 amps, 0.10 amps. So that's how simple to use the Ohm's law. So next is the circuit elements. So first, there are two types of elements found in electric circuits. So the first element are the passive elements. So what are these passive elements? So these elements are not capable of generating energy. So example of these are the resistor, capacitor, and inductor. Muna siya tinatawag na to passive element. So next is the active element. So these are capable of generating energy. So example of these are generators, batteries, operational amplifiers, or op-amp. So next, there are two kinds of sources. So the two kinds of sources are independent sources. So an active element that provides a specific voltage or current that is completely independent of another circuit variables. So it means that, for example, if you have a voltage source, so if that voltage source has a value of 10 volts, so 10 volts redyod ang iyang gina-supply. So it doesn't varies. So constant na. While the other type of sources is dependent sources. That means that an active element in which source quantity is controlled by another voltage or current, such as transistor or pump and integrated circuits. So this is dependent sources is somewhat their values varies depending on the condition that is given on that source. So I'm gonna explain this further later for to better understand. So what are the ideal dependent sources? So these are the symbol for the independent sources. So first is the voltage. So this is a symbol for dependent sources. So we have a circle and then a positive negative symbol. And it can be also a cell symbol. So this is a cell symbol. So two lines and then a positive and negative sign. And for the current is a simple circle and an arrow pointing on which current is flowing. So that is the independent sources symbol. Now, in independent sources, so we have four types of independent sources. So we have a voltage controlled voltage source, current controlled voltage source, voltage controlled current source, current controlled current source. So we have four types of dependent sources. So these are the symbol of dependent source. So we have a diamond and then positive negative for voltage, and diamond with an arrow for a current. So these are the symbol of the dependent sources. So that's all for this chapter, but we need I'm gonna give you an example to an example to make use all of the learnings that we discussed so far. So to give you example here, the last example that we're giving to you. So the problem is here. Calculate the power supplied and absorbed by each element. So it means we need to find the power on this element, this element, this element, and this element. Right? We're gonna use find the power on this element. So So we have here a dependent source, an independent source, and dependent source. So what type of dependent source is this? So to identify the type of dependent source is to check what is the symbol and the equation that is given, or the condition. So since it is a diamond with an arrow, so it means a current. So it is a current source. So it supplies a current. So now let's check the the condition, which is 0.2 times I. So it is called dependent source because of this condition. So kung unsay value ni I multiplied by 0.2, so muna ang current supply by this dependent source. So what is the value of I? So the value of I, which is here, in here. So kani siya. So therefore 0.2 times 5 is the value of this source. So on the source that is being supplied. So therefore, since we know that the condition that is referring to our current, therefore we know that this dependent source is current controlled because it controls by current controlled current source because it gives a current. So that's how you identify the dependent source. So if it is voltage in here, so we know that it is voltage controlled current source. So that's how you identify. So simple siya. So to solve the figure or the circuit, so first is to find the value for P1, so which is here, P1, value of P1. So now, how using again the passive sign convention that I stated earlier. So we're gonna check for the current or the direction of current. So we have a current in this line, so in this line, which is here, naa siya, which has 5 amps. So the direction pointed towards right. So muna siya direction sa current. So it means that the current is flowing from here to this direction, forming a clockwise direction. So we're gonna check the current flow. So the current is leaving to this positive terminal. So this positive terminal. So it leaves, therefore the power, the expected power should be in negative form. So we have negative V times I. So substitute the value which is the 20 volts and the 5 amps in here. So we get a negative 100 amps. So next is to find the power of this load, P2, kaning load. So similar yapon, check the flow of the current. So the current that is entering in this load is also 5 amps, and checking the arrow or the direction that is pointed to is entering to the positive terminal. So using the passive sign convention rule, so therefore the power is in positive format. So substitute the value, which is 12 volts and 5 amps, so we get 60 watts. Next is the P3, which is here. So checking again the current, which is entering again to a positive terminal, so therefore power is in positive. So positive, substitute the value, 8 volts, 6 amps is equal to 48 watts. Now the problem is in the dependent source, which is P4. So first, since we don't know the value of this source, but we know the equation or the condition, so we need to find it first. So since it is a current source, so we assume this is a current, right? I. So I is equal to 0.2 I. So this is the equation, which is the condition here. So we're gonna substitute the value of I, which is I is equal to 5 amps, which is here stated in this circuit. So substitute this 5 amps, so we get 1 amps. So therefore, the current that this dependent source is supplying is 1 amp. So 1 amp na siya. 1 amp na siya na nag-flow in this direction. In this direction. Now, next is to find the voltage. So the problem here is we don't know the voltage of this dependent source because it doesn't have any value that is being dictated. So there's a rule that I will teach you. So this is a basic rule, basic concept that you need to use and remember. So we have these two types of circuit connection. So this is the circuit connection. We have the series, for example. So this box, this box here are resistors or represent as resistor. Then we have this another type of connection here. So sorry for a bad drawing because I'm using a mouse, so it's hard to draw. So there are two types of connection. So we have a series connection and a parallel connection. So how to determine that circuit or that type of circuit is in a series connection or a parallel connection? So to determine the series and parallel connection is to check that their terminals, so the connection of their terminals. So for example, so there's terminal, we have one terminal, this is a 1, and second terminal, first terminal, second terminal, right? So the concept that you need to know that this circuit is a series if one of their terminal is connected to each other. So as you can see, these two resistor, one of their terminal, which is the terminal 2 and the terminal 1 is connected to each other, but the other terminal are not. So therefore, this connection is in series connection. While on a parallel connection, two of their terminal, two terminal ay connected to each other with the other element. So as you can see, the terminal 1 of this element and the terminal 1 of this element is connected to each other, and also the terminal 2 of this element is connected to terminal 2 of this element. And likewise, similar siya sa anipod, ikatulong nga terminal. So therefore, we can assume that this is a parallel connection because two of their terminal are connected to each other. So why are we need to determine what type of connection is this circuit? Because there is a rule that is bound to this connection. So first is in series. So you need to remember is in series, connection is the same, voltage is divided. So what it means that, for example, if there is a current that is flowing in that direction, which is we're gonna put is 10 amps. So therefore, 10 amps po ang experience ani resistor, 10 amps po diri kay currents the same man. But voltage divided means, for example, we have a 10 volts in here, positive 10 volts. So assuming that the resistor in here are on the same value, so therefore divided man, so therefore the voltage in this resistor, which have 5 volts and also 5 volts if the same so this is what we call voltage drop. So na siya voltage drop, nag 5 volts dire, nag-drop siya 5 volts, then nag-drop po siya 5 volts. So muna siyang ginatawag siya og voltage divided in series connection. While on a parallel connections, voltage the same, current divided. So what it means, if we have a voltage in here at 10 volts, so all three terminals in here elements has an 10 volts. Now, experience kasi like 10 volts. But in current, the current is divided. So, for example, if we have a 3 amps in here that flowing in this node, so current divided man, and assuming that this element has the same values, so therefore, each element has a 1 amp in here, 1 amp in here, and 1 amp in here. So, current divided na siya. Mo siyang gitawag current divided. So to remember, in series connection, voltage the same, no, current the same, voltage divided. Parallel, voltage the same, current divided. So, muna siya ang timanan ninyo. So, how are we going to apply this in this problem? So saan siya pag-apply? So, looking at the figure, in this, I'm gonna circle it. So, looking at this figure, kanila silang dua. So, what type of connection these two terminal? So, since both of their terminals, kani terminal, and this is also a terminal, kani. So, connected to each other, therefore, there are in parallel connections. So, using the parallel, the rule or the concept that is bounded on the parallel connections, which is voltage the same, current divided. So, we know that the voltage in this load is 8 volts, diba? So therefore, the voltage in this dependent source is also 8 volts. So 8 volts na siya. So pasabot 8 volts instead dire. 8 volts. Then kapipaste na lang po dayon ang positive yung terminal or positive sign sa terminal, so which is positive sa taas pod, negative pod sa ubos. So now we determine the voltage that is in these dependent sources. So now, using the passive sign convention, so since we know that the current is flowing in this direction, so counterclockwise siya, then dara dire ang positive terminal, so it means that it leaves. So therefore, the power is in negative format. So using the values that is given, which is 8 volts and 1 amps, so we solve the one up here. So we get a power of negative 48 watts. So that's how simple to solve electric circuits. So ano siya, basic knowledge or basic solving na siya. So you will tackle more in further in this particular subject. So that's all. So for this lecture, and thank you for listening.